This is Note-Taking Guide 5.4 for Math 1. So today we're going to talk about composite functions. Sometimes they're called compound functions, sometimes they're called composite. But really what it is doing one function and then doing the other function. It's kind of like putting one function inside another function. So what we're going to do is we're just going to take a look at a couple of examples and then we'll see if you have any questions. So the first thing we need to do is talk about the notation of a composite function. And here it is right here. So it looks like it says fog right there. But what it means is f of g of x. Same thing this direction, f of g of x. What you're going to do when you see something like that is you're going to start back here with the function in the back, and then you're going to substitute that function into the function in the front. So it says the function g is substituted into the function f. And then this one, it looks like it says gof, G-O-F, but it's g of f of x is how you would say that. Again, different notation, but you say it the same way. G of f of x, which means the function f is substituted into the function g. So here we are with our functions right here. We're given our functions, and we're going to go and we're going to do this composite function. So we're going to start at the back. And in the back here it tells me to find g of 4. So my g function is a negative 5x plus 9. So I'm going to go negative 5. Instead of x, I'm going to put in the 4. And then I'm going to do the plus 9. And I'm just going to find that on my calculator. So that will be negative 20 plus 9, so a negative 11. So really what I figured out right here is that g of 4 is a negative 11. I think I'm going to try to write that one more time. This whole part right here is negative 11. So what I've got to do now is I've got to put the negative 11 in to the f function. So once I've solved one of the functions, I'm going to put it through the next function. So I'm going to put the negative 11 into the f function. The f function is 3x minus 5. So I'm going to go 3 times negative 11 minus 5. Punch that in your calculator. And when I did that, I got a negative 38. So my solution for this original problem, f of g of 4 is a negative 38. That's how we do composite functions. Again, we work from the back to the front, and we just substitute into the function it tells us to. So the question is this one's f of g of 4, this one's g of f of 4. Do we think we're going to get the same number going the opposite direction? Do you think we'll get negative 38 again, or do you think we'll get a different number? Well, let's try and see. We're going to start at the back here, which says put 4 into the f function. So the f function is that 3x minus 5. So I'm going to put 4 into that. So 3 times 4 minus 5. 3 times 4 is 12. 12 minus 5 is 7. So this whole part right here just became 7. So now I've got to put 7 back through the g function. So a negative 5x plus 9, in place of the x, I'm going to put in 7. So negative 5 times 7 plus 9, which is a negative 35 plus 9, so a negative 26. So it does not work the same forward and backwards. So even though it was the same number and the same functions, the order did matter here. So negative 38 for the first one, negative 26 for the second one. Two completely different answers there. All right, two different problems again down on the bottom. We're going to do g of f of negative 3, and then we're going to do f of g of negative 3. We know we got to do both of them because order matters. They're in different orders, so we're going to have to get different solutions here. So we're starting in the back with the f of negative 3, which means we're going to put negative 3 into the f function. So the f function is 3x minus 5. In place of the x, I'm putting negative 3. So negative 3 times 3 is a negative 9. Negative 9 minus 5 is a negative 14. So my answer for this part right here is a negative 14. I didn't really write that right. So now I've got to put a negative 14 through the g function. So the negative 14 into the g function will be a negative 5x plus 9. It'll be negative 5 times a negative 14 plus 9. And we're just going to punch that in on our calculator. So negative 5 times a negative 14. And then add 9 to that. And I got 79 for my solution. So my entire solution for that problem is 79. All right, we got another one just like that, but the opposite direction. So this time we're going to start with g of negative 3. My g function is that negative 5x plus 9. I've got to put my negative 3 in the x position. So negative 5 times negative 3 plus 9. When I did that, I got 24. So this whole part right here is 24. And that means I've got to put 24 into the f function. The f function is 3x minus 5. So I'm going to go 3 times 24 minus 5, which is going to be 67 for my solution. Okay. All right, let's look at the last couple of examples and see what we're doing here. So now it says let's do it with f of x equals x plus 4 and g of x equals 6x plus 2. And this time, you guys, we're going to actually, if you notice, it says put x into the g function. Well, x is already there in the g function, so we don't really have to worry about that. It says I'm just going to write that g function inside the parentheses, because that whole thing is g of x there. G of x is 6x plus 2. So really what this problem is asking me to do is to substitute 6x plus 2 into the f function. So my f function is x plus 4. In place of the x, I'm going to put 6x plus 2. So I'm going to go 6x plus 2 plus 4. So I get 6x, and then 2 plus 4 is 6. So my solution for this is 6x plus 6. Now I have lots of students over the years get really confused as to why sometimes we get x's in our solutions and sometimes we don't. Well, I want you to notice right here, inside those parentheses was an x. If there's an x inside those parentheses, I'm going to get an x in my solution. If you notice over here, all of the numbers inside of our parentheses were numbers. They were numbers, so I have to get a number for my solution. So looking back over here at this next one then, I have an x inside my parentheses again, so I should be getting an x inside my solution. So let's try this one and see what happens. This one says take the f of x function and put it inside those parentheses. The f of x function is x plus 4. And then this tells me to take the x plus 4 and substitute it into the g function. Well, the g function is 6x plus 2, and I'm going to put that x plus 4 right next to the 6. So I'm going to have x plus 4 times 6 plus 2. I'm just going to distribute that through now and simplify. So I get 6x plus 24 plus 2. So 6x plus 26 for my solution. Again, I knew I was going to have x's in my solution because there was still an x in my parenthesis to substitute in. All right, last one. This one says put x plus 1 into the g function. So g is 6x plus 2. And I've got to put the x plus 1 in place. So I'm going to go 6 times x plus 1 plus 2. That gets me 6x plus 6 plus 2, which is 6x plus 8. So all of this part right here is 6x plus 8. So now I've got to substitute the 6x plus 8 through the f function. So the f function is x plus 4. And in place of the x, I'm going to put 6x plus 8. Then I still have plus 4. So my answer on that is 6x plus 12 for my solution. So those are composite functions, you guys, where you're putting one function inside another function. Again, just really important to remember, if there's an x inside your parentheses, you're going to end up with an x in your solution. If there's a number inside your parentheses, you're going to end up with just a number for your solutions. So come and see me if you have any questions, you guys. Good luck with your homework.